Hello, this is Mr. Collier, and today we're going to solve systems of equations by using substitution. Okay, so if you recall from graphing, if you have a system of equations, two equations will usually meet at one point called the solution, and at that point the x and the y value or the x and the y value of the solution satisfy both equations. Okay. So if we look at how to do this just algebraically, we know at this point, okay, the y value is going to be the same on both lines. So this y value is exactly the same as this y value at that point only for both lines. And this x value is exactly the same as the x value here, okay, only at that point of intersection. So at the point of intersection, this y is equal to that y. So what we can do is we have y equals x minus 1. So we can take that and substitute it into the first equation. Okay, that's why we call it substitution. So y equals x minus 1. So we can actually substitute it into the first equation. So your first equation is going to become 2x minus 3. And now instead of y, we're going to have what y is equal to, which is x minus 1. That equals negative 1. So it's exactly the same as the original equation, except we substitute in the value for y. Okay, so this part became the y value. Alright, so what we're going to do now is just, we have one equation with one variable we can solve for x right now using this equation. So we've got 2x minus, and I'm going to use the distributive property here. Negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 1. That equals negative 1. So here we have negative 1x, or just negative x plus 1 equals negative 1. I can subtract 1 from both sides. We get negative x equals negative 2. Then we can divide both sides by negative 1 or multiply both sides by negative 1. And we'll get x equals 2. So remember, at the point of intersection, we need the x and the y value. We know that the x value is going to be 2. So now we can find the y value using one of these equations. So actually the best equation to use would be this equation right here, y equals x minus 1, because it's already solved for y. So we can use y equals x minus 1, substitute the value of x equals 2, and you get y equals 2 minus 1, so y equals 1. So y equals 1, x, and x equals 2 at the point of intersection. So your solution is 2, 1. That's the point at which the lines meet, 2, 1. Okay, let's look at another example. Okay, in this system of equations, it's already solved for y. We've got y equals 2, so we can substitute that into the second equation. We've got 4x minus 3 times negative 2 equals 18, and then we can just solve for x. Okay, so we're going to subtract 6 from both sides. We get 4x equals 12, and then x equals 3. Okay, so x equals 3. And then we can, actually we don't need to do any more substitution because we know that the y value is going to be negative 2, so the solution is going to be 3, negative 2. Okay, so that's the solution to that one. And this equation, we've got, both of them are solved for y. Okay, so this is y equals 4/3 x plus 3, and this is y equals negative 2/3 x minus 3. Because they're both equal to y, they are equal to each other at the point of intersection. So you can say 4/3 x plus 3 equals negative 2/3 x minus 3. And now we're going to solve this equation. My first step would be to multiply both sides of the equation by 3 to eliminate the fractions. So this 3 will cancel this 3, you get 4x. 3 times 3 is 9. This 3 will cancel this 3, you get negative 2x, and 3 times negative 3 is negative 9. And we got variables on both sides, so we're going to have to add 2x to both sides. Your variables on one side, we've got 6x plus 9 equals negative 9. And just solve this simple two-step equation. And we get x equals negative 3. So x equals negative 3 at the point of intersection. We just got to find the y value now. So we can use either one of these equations. I'm going to use the first one. Y equals 4/3 x plus 3, and of course x equals negative 3. So we got y equals 4/3 times negative 3 plus 3. 4/3 times negative 3 is negative 4 plus 3, so y equals negative 1. So that's our x and y values at the point of intersection, so the solution is negative 3, negative 1. Okay, next example. Now neither one of these equations is solved for x and y, so we have to do some steps to solve the equation for x or y. If you look at the x's here, the coefficients are 4 and negative 5, so eventually we'd have to divide by 4 or negative 5. So we don't want to solve for x. We want to solve for y here. Will be the easiest thing to do because we don't have to do any dividing after that. So we can solve this for y by subtracting 4x from both sides of the equation. And we have y equals negative 4x plus 6. So now we've got it solved for y. Then we can use this value of y and substitute in right here in this second equation. Okay, so we're going to have negative 5x minus, and instead of y, we're going to use or substitute in this value negative 4x plus 6, and that should be equal to 21. Okay, so then we're going to have negative 5x, and you can think of this as negative 1 times the binomial in the brackets here. So negative 1 times negative 4 is positive 4x. Negative 1 times positive 6 is negative 6. We're going to add these terms together. We're going to get negative 1x, or just negative x, minus 6 equals 21. Let's add 6 to both sides. Negative x equals 27. So x equals negative 27. So we've got our x value. Then we're going to find our y value. Let's use this equation to find our y value. Y equals negative 4x plus 6. And of course x equals negative 27 at the point of intersection. So that's going to be 108 plus 6. So y equals 114. So the solution is negative 27, 114. Okay, one last example. If you look at this one, we have coefficients in front of all the variables, so we're going to have to do a few more steps. And if you look closely, I think the easiest one to solve for would be the x in the first equation, because I can divide the other numbers by 2. I won't get a fraction. So let's go ahead and do that. Negative 2x plus 6y equals 6. I want to solve for x, so I'm going to subtract 6y from both sides. Get negative 2x equals negative 6y plus 6. Divide by negative 2. You get x equals negative 6 divided by negative 2 is positive 3y minus 3. 6 divided by negative 2 is negative 3. So that's my x value. I've solved for x, so we've got 3y minus 3, and we can substitute that in the second equation. Okay, because we used our first equation to solve, now we're going to use the second equation to substitute the value of x in there. Okay, so I'm going to have negative 7 times x, which is 3y minus 3. That equals, oops, not quite, I forgot about this, plus 8y. So that's going to be plus 8y equals negative 5. So I'm going to multiply this out. Negative 21y plus 21 plus 8y equals negative 5. I can do the negative 21y plus 8y is negative 13y plus 21 equals negative 5. And just complete the solving here. Negative 13y equals negative 26. And then we're going to divide by negative 13. And we get y equals 2. Now we need to find the x value. We can substitute it in here. X equals 3y minus 3. So x equals 3 times 2 minus 3, which is 6 minus 3, which is 3. So your solution is 3, 2.